In this video, I'm going to be going through the build process of my new twin screw vise. And the interesting thing about this is that it has gears that link the two lead screws together so they'll both turn at the same time. And what that means is that when you clamp something in one end, it won't close on the other. To get started, I need to glue up a couple of pieces of maple to make one thicker piece. And to do that, I'm going to flatten one side on my homemade jointer before gluing them together. And while the glue is drying on that, I can get started on making the gears. And I've picked out a scrap of 1/2-inch Baltic birch plywood that's big enough for all 5. And then I pasted on the templates that I printed using just a glue stick. There are 5 gears in total, and the 2 on the ends fit on the spindles. And the ones in the middle are what I'm calling the transfer gears, and those turn on 3/8-inch axles, so I'm drilling all those holes now. I'm cutting part of the template away for the spindle gears, and that'll stop the large Forstner bit from tearing the paper off altogether. With that done, I can start cutting them out by first cutting out around them roughly, and then I'm going to clean that up on the disc sander to bring it right up to the tip of the teeth. Now to cut these out, I first started by cutting out each tooth individually, but what I found was that it was easier to make mistakes doing it that way. So what I did was I changed to roughly cutting one side all the way around, and then the other side all the way around to clear out the majority of the material in there. And then I could clean up each tooth individually by nibbling away at it with the blade. The bandsaw does a pretty good job of cutting out the teeth. They're fairly smooth, but they definitely can be improved, and I'm doing that here on my homemade 1-inch belt sander. By the time I finished making all of the gears, the glue had dried on the spindles blank, and I could start machining that by cutting it to rough length and then trimming it down close to the final size on the table saw. And to save a little bit of time while turning it on the lathe, I'm going to trim off the corners on the bandsaw. Now it's over to the lathe where I've got the blank mounted between centers. And the first operation is to true it up and turn it into a cylinder that's the correct diameter. The spindle is not very complex. It does have to be precisely made for the spindle gear to fit on there. And I'm going to start by turning down that shoulder and checking as I go. And I slip the spindle gear onto the tailstock so I can use that to periodically check it. The second shoulder needs to match the hole that will be in the front cover, and I made a gauge from 1/4-inch plywood to check that as I go. The spindle also needs a 1-inch hole for the lead screw to fit into. And this is something that probably should have done while the blank was still square, and I could easily clamp it in the drill press vise and drill that hole. But I'm going to try something else, and it starts by me pinning on a piece of plywood with a 1-inch hole in it. And I'm doing this because that center hole that's in the spindle is bigger than the tip of my drill bit, and what this guide will do is it'll keep the bit from wandering around. Or at least that was the idea, and it probably would have worked if I could have held on to this. But then I remembered that I have a chock for my lathe, and I could put the spindle in that, and then I could take the chock off of my drill press and use that to drill into the end of the spindle. The chuck left some dents in the wood, but I think that these spindles are still a little bit too long anyway, so I'll probably trim that off after. I did the other one in exactly the same way, and now what I'm doing is I'm fastening the spindle gears to the spindles, and I'm using screws to do that with no glue. I want to be able to take these gears off in the future if something happens. I'm using polyurethane construction adhesive to glue the lead screws into the spindles, squeeze some in the bottom, and then push the rod down to force it up around the sides. And while the glue is drying on those, I can get started on cutting out the other parts for the jaws. And here I'm laying out the circular cuts I need in the gear race plate with my compact compass, and then I can clamp that in my quick release vise and cut it out with the jigsaw. And the jigsaw action goes a lot faster when you take out the old worn out blade and replace it with a new one. The next part is the main plate for the moving jaw, and this has 2 holes for the lead screws and 3 for the transfer gear axles. I also need to make 2 recesses in the front side for the 1-inch washers to fit into. And again, I've marked those out with my compact compass, and I'm going to cut them freehand with the trim router. With that much done, I can actually try it out and see how it works and make adjustments if I need to, but this looks like it's working pretty good. The next piece I need to make is the front cover. And I decided to use clear plastic for this because if you've got gears, you might as well show them off. And I've got this sheet that I bought many years ago for a few other projects, and I'm just going to lay that on top of my table saw and cut out the piece roughly with the jigsaw. And that leaves a fairly rough cut, so I'll just clean that up with the table saw. And then I'll make it even smoother by sanding it, starting with rough grit and working up to something really fine. Here's a bit more compact compass action to lay out the holes for the spindles to fit into. And I don't have anything big enough to drill this out exactly, but I do have a hole saw that's a little bit smaller, and I'll use that first, and then finish it on the spindle sander. And it also needs a bunch of holes drilled and countersunk for the screws that'll hold it onto the gear race plate. And again, with that much done, I can put it together and check the action. It's very important when you're building something complex like this with a lot of moving parts to check it periodically to make sure that everything's lined up and working correctly, and make adjustments if you need to before final assembly. Everything checks out, so I took it apart again. And here's something else that should have been done when the spindles were still square, and that's to drill the holes for the handles to fit in. But doing it the hard way always makes it a little bit more interesting anyway. And while I still have this set up, I can drill the hole that will pin the spindle to the lead screw. Next, I need to get started on the fixed jaw parts. And here I've got a piece of 3/4 inch plywood that I'm cutting out into this odd shape. I need for the nuts to be individually adjustable, and these round collars do that. Or at least that was the plan before I messed up. I actually glued the nuts in before the thing was ready, and I had to scrap it and make a new one, and that's the reason why it looks different in the end. Next, I can get the rest of the moving jaw parts glued and clamped together. And then when that's dry, I can glue on the solid wood caps. The last assembly step is to thread the nuts onto the lead screws, and I'm going to hand tighten these with spacer blocks in the jaws of the vise. And what that does is it keeps the jaws parallel while I line up and glue the nut collars to the nuts. And it's important to push the collar up tight and even so that it sits flat on the washer and doesn't wobble as the lead screw turns. I let the glue dry overnight before screwing on the nut collars. And to do that, I'm using 4 in each one. And the purpose of these collars is to allow me to make adjustments if the jaws ever go out of parallel. Then all that's left is to install the handles and to mount the vise on my workbench. All right, showtime. I get to see how it actually works. And it's not bad. I have to admit that it's a little bit stiff, but I'm sure that'll loosen up after I use it a few times. And if you're interested in building one of these yourself, I have plans available on my website. The link to those is at the end of this video and also in the description. My plans are step-by-step and easy to follow, and my projects are always designed to use commonly available materials and hardware, so you won't have to buy anything special.